Welcome back, Algebra Express. We are in Rockswold 4.7. Now we are finally going to start solving these things. This section is all about rational equations. So we're taking everything we did with rational expressions, and now we're throwing in equal signs, and we're going to ask for values of x that make the original statement true. Or we can also call these things solutions. We're going to find solutions to these things, values for x. Okay, so they kind of tell you how to do things here. If it's got a denominator and we don't want a denominator, the approach to getting rid of the denominators is to find the least common denominator, and then we're just going to multiply straight through by the least common denominator. And if you do that, it will get rid of your fractions. So we can do this with polynomials. You can also do this with, I guess, if you have like a regular polynomial with what? Fractional coefficients. You could probably also use this approach. Okay, so I'm looking at this thing 2 over x equals 3 over x plus 2 plus 1. So if I'm looking here, there are really only two denominators I need to think about, my x and my x plus 2. This 1 is just sort of like 1 over 1. If we want to write it that way, we could. But I'm just trying to find my LCD. Right off the bat, I have an x. And I have another thing that looks like x plus 2. So my LCD is I put those two things together. So my LCD here is x and x plus 2. And so I want to take this equation. This looks like 2 over x. And so now I want to multiply this by x times x plus 2. And so what I'm doing is I'm multiplying by x times x plus 2 here. And if I do it to the left side, and I don't want to change things, multiplicative property of equality, right? If we multiply the same thing to the both sides, it's not going to change my equation. My equation should. So we're multiplying by x and x plus 2, and I kind of wrote it this way because if we want to, and if it helps you, you can always put this thing over 1. And so I have 2 over x over here that's getting multiplied by it. And I've been trying to lead up to it slowly, but this I have to multiply by two different things. So one of them looks like 3 over x plus 2. And I'm multiplying this by x and x plus 2. So I have to distribute this to both of the terms that are on this side. And I still have a plus. And this gets multiplied by a x and an x plus 2. So if it helps you to write it over 1, you can always do that. Here you can write it over 1 if you want. You don't really need to on that last one. It's just going to be 1 times that. Ooh, excuse me. All right, so I'm looking along here. I'm multiplying these two things. So if I did this correctly, everything on the bottom should simplify out. And I believe so. This should simplify with this. And now I have something that looks like 2 times x plus 2. This is all over 1. There's only 1s on the bottom. So we're looking along here. I see 3 over an x plus 2. And so I see an x plus 2 here, and I see an x plus 2. This looks like 3 times x, or 3x. And now everything should be over 1. That's just 3x. So this is plus 1 times 1 times x plus 2. I guess I'll put the 1 there. It doesn't really matter if you write the 1. You just do it 1 times. So this is 2 times x plus 2. So now we have a little bit of distribution to do. So this looks like 2x plus 4. This looks like 3x. This looks like plus x times x is going to be x squared plus 2x. So after I do some distribution, you might notice that the highest power here is a square power. So we should be getting 2 solutions for this thing. And we want to solve this thing like a quadratic. So there are a few like terms made combined. 5x over here. And then I want to what? Subtract 2x, subtract 4. X squared minus 2x minus 0. And now I need to factor this thing and solve it. So I'm factoring this thing. And so 1 and 4 should be the numbers. And this is equal to 0. And so we've done this a few times. So the 2 solutions I should be getting are x equals 1. X minus 1 equals 0. X is a positive 1. X plus 1. Okay. And so we are saying this is a solution. We are saying this is a solution to this thing. So what we should really do is we should go back in and check this and make sure that these both work as solutions to this equation. Okay. And so there are 2 basic ways to sort of check these solutions to make sure whether or not they are extraneous. One of them is to go and actually check if it is a solution. So we do 2 over 1 over what? 1 plus 2 plus 1. Does this make a true statement? This is what we're trying to figure out. So 2 over 1 is 2. 3 over 3 plus 1, or 1 plus 1, 2 equals 1 plus 1. I think we're close enough there. The other thing is a minus 4. So if I go ahead and plug in a minus 4, 2 over a minus 4 equals 3 over a minus 4 plus 2. 1. 2 over minus 4 is a minus 1/2. Is this equal to minus 1/2? This is 3. And minus 2 on bottom. This is a minus 3/2 plus 1 is a minus 1/2. So these both check as solutions. They will work if we go plug them back in. I didn't talk about it before I started this one, but if I wanted to talk about the domain, there are 2 things that are restricting this domain. This denominator and this denominator. So this denominator cannot be 0. So one of them is x not 0. And the other thing with the domain is this thing cannot be 0. So x cannot be a minus 2. You might notice none of those things match up. So that is good. Okay. So our 2 solutions for that first one, just to recap, are x equals 1 and x equals minus 4, and they both check out. Neither of them are extraneous. So it is possible that you might get extra solutions in these rational equations that we have to pick out. And so we might end up getting some of those like that on this. I'm pretty sure. For the function, so now we're using the same concept, but now we're throwing a little bit of function notation into here. For the function f of x equals x minus 5 over x, solve f of x equals 4. What is the point on the graph of f? So we want to solve, so first thing, let's just solve this thing, and then we'll talk about the point on the graph. So if we want to solve this thing, this is my equation. This is what they give me my equation equal to expression number. So that is setting up from what they say. They say f of x is this equation, and then they give me a number to plug in for it. I'm plugging in a number for f of x. I should get this thing. Now, the approach is to find the LCD. So my LCD here, I have one denominator to think about, one denominator to care about. The only denominator I see here is x. So my LCD here should be x. Okay. So I want to multiply everything by x. I want to multiply this side by x. I want to multiply this side by x. So if I multiply sides by x, usually you're going to end up having to do some distribution on this step. So x times x is the first thing I'm seeing here, or x squared. The next thing I do is x times 5 over x. So this is sort of like I'm doing x over 1 times 5 over x. And this is equal to 4x. Okay, so if I write it out, and I wrote out probably more steps than I will in the future, but here we go. Out. And so this looks like x squared. If I multiply an x by 5 divided by x, that's just going to give me minus 5. So I'll probably just skip from like this thing to this thing if I were doing this. All right, but if you have to write out middle steps, that's good as well. I have an x squared minus 5 equals 4x. If I want to solve this as a quadratic, the steps to solve a quadratic is to set one side equals 0 and factor. So now I have something that looks pretty similar to stuff that we've done before, hopefully. And I want to factor this thing. So I believe this is going to factor with a 5 and a 4. 5 and 1, sorry. And if I want to make the 4 negative, the 5 is going to be the negative. So I have one that looks like x minus 5 is 0. I got one that looks like x plus 1 is 0. I got one that looks like x is 5. I got one that looks like x is a minus 1. So these are the two potential solutions. So I have these things. I want to go and plug them back in and see if they make this statement true. One of them looks like 5 minus 5 over 5. Is that equal to 4? And it looks like minus 1 minus 5 over minus 4. Is that equal to 4? 5 minus 1 is equal to 4 minus 1 plus 5 is going to be equal to 4. So this is a double negative, it becomes plus 5. So both of these should check out. Okay. So I found my solution. I found half of probably what they asked for here. Find this is the function, solve that. So we solved for this. We've solved for the two values of x that make this true. Okay. And what is the point on the graph of f? So if my x is 5, what is my y here? And the y is the thing that they are giving you in the problem. So f of x is my y quantity, which is 4. So I have 2 points. One of them looks like where my x is 5 and my y is 4. The other one looks like where a minus 4, or x is minus 4, y is 4. Okay. Now we want to find an LCD of this thing. So we have an x minus 5, we have an x squared minus 25, and we have an x. So hopefully if you're looking at these, the thing that you notice that might look different is that we have something that looks like x squared minus 25 on bottom. So if that's the case, we can really think of x squared minus 25 as this is a difference of squares. We really want to factor things if we're going to find an LCD. So this is an x plus 5 and an x minus 5 combined. So if I'm thinking about my LCD, this guy right here, I have an x minus 5, I have an x plus 5, I have an x minus 5, and I have an x. So I have to count for everything at least once. I guess if you want to write all three of your denominators up there, we got to count for everything at least once. So we got to count for the x. We got to count for the x plus 5 once. And we have to count for an x minus 5. So this is my LCD, x times x plus 5 times x minus 5. Okay. And so we're multiplying that. We're multiplying it to each and every term that is in here. We're multiplying it to the right side and to the left side. So if I multiply it to both sides, I have to distribute it to every term. This is the thing I'm multiplying. X, x plus 5, x minus 5. And I would keep things over x minus 5. And I'm multiplying this by my LCD, which is x 5 and an x minus 5. And if you have to put this over 1, you can always put it over 1. Let's get some scrap paper on this. This is going to go long. And I'm going to subtract. I'm going to subtract 20 over. And I'm going to keep this factored into x plus 5, x minus 5. We factored it already. Keep it factored. And we want to multiply this by x plus 5 by x minus 5. And we have to put it over 1, but this is going to the top. And this is equal to 3 over x. And I got to multiply by x, and x plus 5, and x minus 5. Maybe I don't want x. Alright, so they should start simplifying. And if you do enough of these, you might be able to jump maybe one more step. You might be able to jump to this next step where you say, well, I know the x minus 5 is going to just 2x and an x plus 5. I have a minus 20 times something. This x plus 5 and this x plus 5. x minus 5, this x minus 5. 20 times x, what's left on top. And this is equal to, and now I'm looking at this thing, my x here and my x here. I got 3 times x plus 5, x minus 5. Okay, so now we have to do probably a wee bit of distribution. So x times x is going to be plus x. X is equal. And I think I got it down to one page now. So this looks like 2x squared. I actually got a little bit of distribution to do. And now I got to think about starting to combine these things. So this is a quadratic again. Quadratic. And so I think I'm going to subtract 2x squared over. This will give me a minus 10x over here. If I subtract my 2x over, this gives me an x squared minus 75 on this side. So I think all in all, I'm going to do x squared plus 10x minus 75 is equal to 0. When I move the 10x over. Okay. I believe the magic numbers on here are going to be 15 and 5. X and 5. And if I'm looking at this for the 10 to be positive, the 15 would be positive, 5 would be negative. And we want to solve these things so x plus 15 equals 0, x minus 5 equals 0. So I'm getting x equals a minus 15 here. I'm getting x equals 5 here. Okay, so these are the solutions I'm getting. These are potential solutions. So we still need to go back in and check these things and make sure they still work. So 2 over a minus 15 minus 5 minus 15. 5. Check if this is true. This is 2 over minus 20 minus, what was this? 15 squared is 225 minus 25 is going to give me 200 minus 20 over. Equal to, what is this? Minus 1/5. This looks like a minus 1/10. This looks like a minus 1/10. Is that equal to minus 1/5? So minus 2/10, I believe, is the same thing as a minus 1/5. So this one should check out. So this one checks out. All right, so what about x equals 5? I want you to go plug this thing in, see if it checks. 2 over 5 minus 5 minus 20 over 5 squared minus 25 equals 3 over 5. Okay. I don't know how long you want me to stare at this, but this is giving me over 0. This is giving me over 0. This is not going to work. It's giving me an undefined term, something over 0. It does not exist, does not compute. It is no good. This thing is extraneous. We cannot use this. So a little bit about what else we could do. So if we want to know the domain of this thing, if we're looking here, we have x minus 5 in the denominator. So that tells me x cannot be a positive 5. We also have this x squared minus 25 here. So this also tells me that this thing cannot be 0. So that also gives me x cannot be a minus 5. And the last thing I have is x cannot be 0. So I have these 3 restrictions on my domain. If we go back, look at the solutions, minus 15 is not a restriction, but 5 is. So if you want to look at your domain restrictions before you start doing these, and you want to get your domain, and then you want to verify that none of your solutions are in your domain restriction, then that is one way you can kind of check your solution. The other way you can check your solution is you can literally check your solution by plugging it back in and seeing if it is a solution. So if it gives you a true statement, you're good. If it's giving you something that's like being divided by 0, that's not working. It's not good. That's extraneous. And if we're looking, there is something we did somewhere along the way, I'm sure. We probably simplified an x plus 5 with an x plus 5 on this one, I believe, right? And you can only do that if this is not 0, right? Anytime you get 0 over 0, we can't use that rule. Because 0 over 0 is indeterminate, it's not 1, right? So hidden somewhere in your work was the fact that it was not 0, is what you were assuming. And even here, right, in our original statement, it cannot be 0. Or x cannot be 5. Okay. The last problem. Long story short on that one is you got to go plug them back in. Or if you don't go plug them back in, you got to check it with your domain restrictions. So this one right off the bat, if we did want to just open up with the domain restrictions. There's one thing with a variable in the denominator, it looks like x minus 8. So we want to know where this is 0. We add the x over, I think that gives us x equals 8. This is where that's going to be 0. So my x cannot be 8. If we get that as a solution, we're going to have to reject it. The other way is we can always go plug things back in. And it doesn't hurt to do both, right? Find out your domain. It's not too hard usually, especially if you have things factored. It's usually pretty quick. And do a sort of double check on yourself. If we want to do this, we do butterflies. If we have something that looks like a fraction equals a fraction, it's a single fraction. There's no adding, subtracting different fractions. It is just one thing over another, one thing over another. We can do this sort of thing, the butterfly. We can do a times d times c. Or cross multiplying, I guess is the more professional term. If we're being honest, if you look at this property, a over b and c over d, right? This is really the same thing we've been doing, but my LCD here is bd. So I multiply by bd both sides. You might notice you're getting the same thing. So it's a shortcut of what we're basically been doing, right? AD and CB. Okay, so with that said, let's go ahead and do this one. If we go right through here, I look at x times 8 minus x should be equal to the other things being multiplied 3 by 4. Okay, so I got to do a little bit of distribution now, a little bit of multiplication. 8x minus x squared is going to be equal to 12. And I think I'm going to move this to the other side just so I can have my x squared positive. I'm going to subtract my 8x, and I'll have plus 12, and this is equal to 0. So I set one side equal to 0 on this thing. And now I want to factor and solve this thing. So I'm factoring and solving. 2 and 6. And I believe they both have to be negative. I'm getting x equals 2. I'm getting x equals 6. So this is the potential solution. This is the potential solution. I want to go back. And they should both be valid solutions, right? Neither of them is 8. But if I want to double check this thing, let's go 2 over 4. 3 over 8 minus 2, we can check that. We can check 6 over 4 and see if that is 3 over 8. 2/4 is a half. Is that equal to 3/6? I think it's good enough. Those are equivalent fractions. 6/4 is the same thing as 3/2. Is that the same thing as 3 over x minus 2 gives me 3/2? Both of these should check. Okay, so that is the final problem on this homework, or not on the homework, on these notes. See you soon in class. Take care.